In this lecture, naming is going to get slightly more complicated. The previous naming that we did, we are restricting ourselves to the first four homologuses, and we're going to do the naming of the rest of the molecules later. Now, we're going to first discuss what do we mean by branches. What is considered a branch? So now, previously we were discussing only straight chain molecules. Now branches would look like this. For example, if you have a carbon chain, let's draw a really long carbon chain, and there would be now this carbon chain is slightly more complicated. It's not a straight chain because there are carbon molecules which are coming out from the middle. So these are not simple straight chain molecules. So let's say there's another carbon chain over here, and there is another carbon chain in the center on top. Now if you look at this particular molecule, you'll see, and let's draw all the hydrogen atoms. Let's fill in all the hydrogen atoms. This is going to have, it's going to have 3 hydrogen atoms. This is going to have 2 hydrogen atoms. This would have 2 hydrogen atoms. This has a total of 3 hydrogen atoms, and this has a total of 2 hydrogen atoms. So this has a total of 2 hydrogen atoms. This has a total of 3 hydrogen atoms attached to it. The bonds of this carbon atom are complete, making 4 bonds. This has 1 hydrogen atom, and this has 3 hydrogen atoms. This is also going to have 3 hydrogen atoms. Now if you look at this molecule, it's slightly more complicated than the ones that we discussed earlier. Now if you carefully observe this molecule, you can the longest carbon atom chain is probably this one. It's a continuous group of carbon atoms which are arranged continuously. So if you think of this as a tree, then you will have these branches which are coming out from that tree trunk. So the 2 carbon atoms coming out from this side, and there's 1 carbon atom coming out from this side. Now when we talk about branches, we would refer to, this would be our main chain. Now our main chain is going to be it's going to be the longest continuous carbon atom chain. Now one important thing about this chain is that it's not necessary that the chain is a straight chain. It could be bent as well. So let me draw another molecule. Let's come up with another molecule, and this molecule has, let's say it has, now it's a molecule like this, and let me draw all the hydrogen atoms. This is going to have 3 hydrogen atoms. This carbon is going to have 3 more hydrogen atoms. This particular carbon has 2. This one is going to have 3 hydrogen atoms, and this carbon is going to have 2 hydrogen atoms, and this is going to have a total of 3 hydrogen atoms. Now if you look at this molecule, the longest continuous carbon atom chain is going to be this one. It's going to start off from this carbon atom, and then it's going to move to the top, and I'm encircling all the carbon atoms. So this is going to be your longest continuous carbon atom chain. So it's not important point is that it's not necessary, it is definitely not necessary that the chain is straight. So it's not necessary that main chain is straight. So that is not an important point. So if you look at the carbon atoms, that's the only way these carbon atoms, there are 1, 2, 3, 4, 5 carbon atoms occurring in a continuous fashion. So the stress should be in the longest, it should be the longest continuous carbon atom chain. Whether it's straight or bent or zigzag, that's not going to be important. Another important factor that determines which one is going to be the main chain, that important factor is the main chain. When deciding what the main chain is going to be, the main chain is going to have the maximum substituents going to have the maximum substituents, or we can say it's going to have the maximum number of branches attached to it. So there could be many candidates for a main chain. For example, even if you look at this previous molecule, there were 5 carbon atoms. I took this as my main chain, the one that I'm highlighting in green. And this main chain had how many groups, substituent groups or branches attached to it? It had 1, 2, and 3 branches attached to it. Now, that was the main chain that we decided for that particular molecule. Now, if we go back and change our main chain, our previous main chain had 5 continuous carbon atoms attached to it, and that was the maximum. But there could be many different main chains in this particular molecule. For example, these 5 carbon atoms are also occurring in a continuous fashion. So I can take that as my main chain as well, because it's just as long as the previous main chain. The only problem now is that how many substituent groups is it having? It's only having 1 substituent group on the right hand side and 1 substituent group on the left hand side. So we're not going to take that as a main chain. Our main chain is going to have the maximum number of substituent or groups or branches attached to it. So let's clear that. So this is how we're going to decide the main chain. We're going to decide the main chain. Let's sum it up. We're going to decide the main chain. It's going to have the longest continuous carbon atom chain. So they should be in a continuous fashion. It's not necessary that all the carbon atoms are in line, are arranged in a straight line. They could be in a zigzag fashion, like the molecule that we discussed over here. The 5 carbon atoms were occurring in a continuous fashion, one after the other, but they were not in a straight line. This could be taken as a main chain. This is in fact the main chain of this molecule, because the straight chain is going to have just 4 carbon atoms. So the maximum number of carbon atoms are going to occur if you go from this carbon atom and then move upwards. So it's not necessary that the main chain is straight. And the last important point is that the main chain is going to have the maximum number of substituent groups or branches. And we're going to discuss this further now. While naming more complicated molecules, we must also introduced alkyl chains or branches. We've previously discussed what main chains were. Alkyl chains are, let me give you an example of a molecule. Let's draw a simple molecule, and this is going to have 3 hydrogens, this is going to have 3 hydrogens, this is also going to have 3 hydrogens, and this is also going to have 3 hydrogens. So I'm not going to draw the full displayed formula, but just a simple more compact formula. And let's start off. The first thing that you need to figure out when you're trying to name a more complicated molecule which has branches, is that you figure out what the main chain is in this particular molecule. The longest continuous carbon atom chain is going to be this. It's going to have a total of 3 carbon atoms. Let's draw that again. So it's going to have a total of 3 carbon atoms. And while we are at it, it's going to have 2 branches. This is the first one, and this here is the second one. Now these branches, if they are carbon branches, they're called alkyl. And there's a general formula for these branches. The general formula is, when we're going to try and name those branches as well, and the general formula is, for an alkyl branch, the general formula is, it is CnH2n plus 1. And the suffix for an alkyl branch or an alkyl group is, the suffix is going to be, the name is going to end with YL. So for example, if we have a methyl branch or a methyl group, that means it's an alkyl group. And meth means that there are how many carbon atoms? Meth means that there is a total of 1 carbon atom. So it would be C1, and H would be 1 into 2 plus 1, which is going to be 3. So it's going to be CH3. So methyl would be CH3, and in this case, since this is CH3, so this is a methyl branch. This also is a methyl branch. Similarly, you'll have ethyl branches, an ethyl branch. So an ethyl branch or ethyl branch would have 2 carbon atoms, because Eth means that there are a total of 2 carbon atoms. So if you go by the formula, it would be 2 into 2, 4 plus 1, that would be 5. So C2 and H5. Let me give you an example of a molecule that has an alkyl and an ethyl group or an ethyl chain. For example, we have a total of 5 carbon atoms, and there are 2 carbon atoms on this side, and there's 1 carbon atom on this side. And let me draw all the hydrogen atoms. So there are going to be 3 hydrogen atoms with this. There's going to be 1 hydrogen atom with this carbon atom. 3 hydrogens would be over here. This is going to have 1 hydrogen. This is going to have a total of 2 hydrogens. This is going to have a total of 3. Then 2 hydrogens over here, and finally you have 3 hydrogens on this last carbon atom. Now if you look at this molecule, what's the longest carbon atom chain? The longest carbon atom chain in this particular case is it's probably going to be this one. So that's your longest continuous carbon atom. So how many branches do you have? You have 1 branch over here that has 1 carbon atom, and you have another branch over here which contains how many carbon atoms? It has 2 carbon atoms. So if it has 1 carbon atom, this branch would be called a methyl branch. And if you look at the general formula, the methyl branch, let me draw it with another marker. So a methyl group, this one over here is going to be a methyl branch, and this one over here is going to be an ethyl branch. And you can count the number of carbon atoms. An ethyl branch is going to have 2 carbon atoms, and it's going to have a total of 5 hydrogen atoms. So this is an ethyl branch, and it fits exactly with the general formula that we discussed earlier. Similarly, if you look at this branch, this has one carbon atom and it's a methyl group, which means that it contains 3 hydrogen atoms. So it's going to be C1 and H3. So this is a methyl branch. So remember how to name branches, especially if the branches are carbon branches. They would be called alkyl groups, and this is how you're going to name those alkyl groups. We will now learn how to name systematically branched alkanes. So, naming of a branched alkane will be done in 3 parts. The first one is you need to identify the main chain. So, you're going to start off with the main chain. I'm writing this in the order in which the name is going to appear. And before that, you would mention the number of branches or the substituent groups in that particular molecule. And before that, you're going to you're going to write down the positions of all the substituent groups or branches in that particular molecule. So the naming would be done in that order, and you're going to start off with the main chain first. Then we're going to identify the number of branches, and we're going to write down the branches. And then before each branch, we're going to give the position of the branch. And I'll explain to you in detail how this would be done. And we're going to start off with the simplest branched molecules first. For example, let's say I have a molecule. Let's say it has 5 carbon atoms. And there is a carbon atom, there's a branch of carbon atom on one side, and let's write down all the hydrogen atoms. There would be 3 hydrogen atoms. Let's use another marker for that. Now let's say there are going to be 3 hydrogen atoms with this carbon atom. They're going to be a total of 2 hydrogen atoms with this carbon atom. 2 hydrogen atoms with this carbon atom. There's only going to be 1 hydrogen atom with this carbon atom. This carbon atom is going to have a total of 3 hydrogen atoms, and this carbon atom would also have a total of 3 hydrogen atoms. Now, if you look at the molecule, the first thing you would notice is you're going to identify the main chain. We're going to start off with the main chain. So we're going to identify the main chain in this molecule, which is the longest continuous carbon atom chain, and it's going to have the most substituent groups. So in this particular case, the main chain is no doubt it's the straight chain that is starting. So in this case, this is your main chain, and it has how many carbon atoms? It's going to have a total of, if you count, it's going to have 1, 2, 3, 4, and 5 carbon atoms. And since it's an alkane, you're going to identify the homologous that it's coming from. So since it is an alkane, your main chain, the name of your main chain, which has 5 carbon atoms, the 5 carbon atom name starts with pent. And since it's an alkane, the name is going to end with the suffix is going to be "-ane". So that's the first thing. We've gotten rid of the main chain. We've named the main chain. Now we're going to focus on the branches. And there's only one branch over here. And that branch has 1 carbon atom. So since it has 1 carbon atom and it's an alkyl group, it's a carbon atom branch. So 1 carbon atom, the branch would be called, methyl. We just did alkyl group, so the branch is methyl. And finally, we have to write down the position of this branch. Now, when we talk about position, what we mean is that what's the position on the main chain. So position or carbon number on which carbon number on main chain. So when we talk about position, we're talking about where this particular alkyl group is attached. So this alkyl group is attached to this carbon atom over here. I'm marking that with an arrow, and I need to give the position of that carbon atom. So I have to give the position of the carbon atom on the main chain. So there are two things I can do. I can start counting the number of carbon atoms. For example, if I count from the left hand side, this carbon over here is basically carbon number 2. So if I count from the left hand side, this side, then this particular carbon atom is carbon number 2 from the left. This is the first carbon atom, this is the second carbon atom. And if I count from the right hand side, if I start counting on the main chain, then this is carbon number 1, this is carbon number 2, this is carbon number 3, and this would be carbon number 4. And we've discussed positions before. You always count from the side which is going to give the smaller number. So you're not going to count from the right hand side because you're getting a smaller number from the left hand side. So you're going to cut this out. And you're going to take 2 as the position because it's coming out to be a smaller number. So you're going to count the position of this particular branch and where it is located on the main chain. So it's on the second carbon atom where this chain is located. So the name of this molecule is going to be, the position is going to be 2. The branch is going to be methyl, and the main chain would be called pentane. Now let me discuss a few things more. How we're going to write this name. The name is 2-methylpentane when spoken, but how would you write this particular name? So there are a few more points that you need to learn. The first point is, point number 1, there's no gaps between a letter and another letter. Between an alphabet and another alphabet. Second point is, there's going to be a dash. This is what a dash would look like. There's going to be a dash between a letter and a number. And the third point is, there's going to be a comma between a number and another number. So this is how we're going to name. So if I write that particular name, which was 2-methylpentane, so it's going to be 2, and then there's going to be a dash between a letter, which is methyl, and there's going to be no space between methyl and pentane. So this is how you're going to write this. So you should learn the rules of writing names. These are some rules for writing a name of an organic molecule. There are some other branches that we need to study as well. They are not just alkyl branches, but a lot of other branches that also exist that are of different types. For O levels, we're going to keep it simple. We are only going to study branches other than alkyl branches that contain halogens or group 7. So these halogens are group 7 elements. Now these branches, the way they're going to be named, and they would be, for example, if you have chlorine occurring as a branch, then it would be called chloro. If you have bromine occurring as a branch, that would be called bromo. And if you have iodine occurring as a branch, that would be called iodo, and so on. Fluorine would be called fluoro. So these branches, the way they're going to exist in a particular molecule is, for example, if you have a 3 carbon atom alkane and there's a Cl branch, they would always be considered as branches. And let's complete all the hydrogen atoms. This would have 3 hydrogen atoms with it. This is going to have just 1 hydrogen atom, and this is making 1 bond. It needs 3 more hydrogen atoms. So this here is a molecule, and I want to name this particular molecule. So I'm going to look for the longest continuous carbon atom chain, which is going to be this one. It's this particular carbon atom chain, and there are 3 carbon atoms, which means that the main chain has its name is going to start with prop, and since it's an alkane, it would be called propane. And this Cl atom is existing as a branch, so this branch would be called chloro. And the position of this branch, if you count from either end, if you count from this side, if you're counting from this side, this is 1, and this carbon atom, this is 1, and this carbon atom would be 2. Whereas if you start counting from this end, then this would be carbon number 1, and this would still be carbon number 2. So from either end, there's no confusion with this chlorine. Its position is 2. So the name of this particular molecule is going to be, you're going to start off with the position, it's going to be 2, and then you're going to have chloropropane. So that's your name for this particular molecule. Now in a similar way, you can name it using we can use another halogen. We can call it bromo or iodo. Let me give another example. Let's take a 4 carbon atom, and there's Br attached on this particular carbon atom, and let's complete all the hydrogen atoms. This is going to have 3 hydrogen atoms. This is making 3 bonds, so it just needs 1 hydrogen atom. This is making 2 bonds right now, so you need 2 hydrogen atoms with this, and this is going to have 3 hydrogen atoms. Now I'm going to again look for the longest continuous carbon atom chain, which in this case it's this particular carbon atom chain. So this is the longest carbon atom chain, and the name would be, it's 4 carbon atoms, so the name is going to be, it's going to start with but, and it's an alkane, so it's going to end with ane, and this bromine is occurring as a branch, so that's bromo. And the position of this particular branch, if you count from this side, it's going to be 1, 2, it's attached to the 3rd carbon atom. But if I count from the other end, then this would be carbon number 1 and this would be carbon number 2. So I'm getting a smaller number from this particular end. So I'm going to write the position. It's going to be 2 bromobutane. So remember, apart from alkyl chains, you also have branches which consist of halogens, and they would be named accordingly. They would be called chloro, bromo, or iodo, and you're going to give the position and name the molecule exactly like I taught you guys before.